How do you make a perfectly round sphere without ever touching it? No hands, no machine, no mould. It sounds impossible, but that is exactly how these are made, every second, by the hundreds. In 1588, two Englishmen couldn't decide who would marry the same girl. They didn't fight. They settled it with a game of glass marbles. The winner took the bride. And ever since, that village has held a world championship every year. Grown men warming up their thumbs while judges measure the marbles with callipers. And this is what they're made from today, a mountain of broken bottles. In 6 hours, it will become 1 million perfect glass spheres, and they will become round all by themselves, because molten glass wants to be a sphere. I'll show you exactly how near the end. It's one of the most hypnotic things in all of manufacturing. But first, a question. Did you have marbles as a kid? What color was your favorite? Clear with a blue swirl, a cat's eye, milky white, or that one big one worth 3 normal ones? Write the color of yours in the comments. I genuinely want to know, and the answers always reveal what country and generation you're from. And if you love finding out how ordinary things around you actually work, subscribe. Every week we crack open another industry nobody thinks about. The history of marbles is far older than most people imagine. People played with them long before factories existed. Archaeologists have found round clay and stone marbles in ancient Egyptian tombs, in the ruins of Rome, in Mesopotamia, thousands of years old. Children played marbles under the pharaohs. Roman boys rolled nuts and stone balls along the pavement, and Roman writers even said that giving up marbles was what it meant to grow up. Humanity has been playing this game for its entire recorded history. But real glass marbles were a luxury for a very long time. They were blown and rolled by hand, one at a time, and they were expensive. In the 19th century in Germany, in the town of Lauscha, the heart of glass blowing, a craftsman invented special scissors that could snip off a drop of molten glass and roll it into a ball. That sped things up, but every single marble was still shaped by human hands. Poor children played with clay. Everything changed in early 20th century America. A man named Christensen invented a machine that made marbles without hands at all. A stream of molten glass simply turned into a stream of identical spheres. Output multiplied hundreds of times, the price collapsed, and suddenly glass marbles were affordable for every child on the planet. America began producing them by the billions. An entire town in West Virginia lived off this industry, and there's still a museum there dedicated to nothing but marbles. In just a couple of decades, marbles went from a rare treasure to something rattling in the pocket of every kid from New York to Tokyo. And since we're talking about the game, here's the fact worth staying for. In England, in the tiny village of Tinsley Green in West Sussex, the World Marbles Championship is held every year on Good Friday. Not as a joke, a real one, with judges, rules, and competitors from different countries. Local legend says the tradition dates back to 1588, when 2 young men couldn't decide who would marry the same girl and settled it with marbles instead of fists. They've played every year since. And the rules are serious. Players gather around a circular concrete ring covered with sand. 49 marbles are placed in the center. Teams of 6 take turns flicking them out with a thumb. Whoever knocks out the most wins. And here are the details that are both hilarious and wonderful. Before a match, players warm up their thumbs because a cold thumb shoots weaker. Judges have the right to measure a marble with calipers. If it's oversized, you're disqualified. And moving your hand while shooting, called fudging, is cheating. Grown men, many of whom have been playing for 40 years straight, seriously compete for the world title in a children's game. And for years, German teams kept winning. They arrived properly trained. So a marble isn't just a piece of glass. It's a toy with a world history, its own champions, and its own museum. Now let's go back to the factory and to that mountain of broken glass we started with. Today, most marbles aren't made from fresh, raw materials at all. They're made from recycled glass, the very waste we throw away. And this is genuinely one of the great recycling stories on the planet. Glass is a unique material. It can be melted down again and again, forever, without losing quality. Paper degrades when recycled. Plastic degrades. Glass doesn't. The bottle you threw out yesterday can become a marble, then a bottle again, then fiberglass, endlessly. It starts with collection. Glass arrives from recycling centers and sorting plants in mountains. The first job is cleaning it because everything comes along with the glass: caps, labels, leftover liquid, plastic, metal, ceramics. And here's a detail almost nobody knows. The worst enemy of a glass factory is ceramic. A shard from an ordinary plate or mug won't melt at glass temperature. It stays a solid stone inside the melt, and that invisible pebble ruins the finished product. So factories use optical sorters, cameras, and sensors that identify what's flying past on the conveyor and blast out the intruders with jets of compressed air. Magnets pull out metal. Fans blow away paper and labels. Then the glass is crushed. Huge crushers turn bottles into fine fragments that the industry calls cullet. And here's another reason recycling wins. It isn't only about the environment. Cullet melts at a lower temperature than raw sand and soda. Every ton of cullet added saves the factory fuel and electricity. So recycling glass isn't just the right thing. It's cheaper than making new glass. That's exactly why the industry does it without anyone forcing them. The crushed glass is then mixed with additives. If you want a perfectly clear marble, you use the cleanest, colorless cullet. And then comes the alchemy of color. The color of glass is metal, not paint, not pigment. Actual metals dissolved in the melt. Cobalt gives deep blue. Chromium gives green. Manganese gives purple. Iron compounds give brown and olive. Selenium and gold give red, which is exactly why truly red glass has always been the most expensive. A colored marble is, quite literally, a piece of glass with metal dissolved inside it. Now the mixture goes into the furnace, and this is the hottest place in the entire operation. A glass furnace is an enormous bath of refractory brick where the temperature reaches around 1,400 degrees Celsius. For comparison, lava flowing from a volcano is usually cooler than that. Broken glass goes into that furnace as cold rubbish and comes out as a glowing orange liquid, thick as honey. And here's a fact that changes how you see glass forever. Glass isn't really a solid in the normal sense. Metal or salt has a strict crystal lattice inside. Glass has none. Its molecules sit in a chaotic arrangement, exactly like a liquid, just frozen in place. Scientists call this state amorphous. Put simply, glass is a liquid caught mid-motion and frozen. And that's precisely why it's transparent. There's no internal structure for light to catch on, so it passes straight through. The furnace runs around the clock for years without ever stopping. You can't switch it off overnight. If you let the melt solidify inside, you can throw the whole furnace away. That's why these factories burn 24 hours a day for decades. From the furnace, the melt travels along a channel, a thin, glowing river. And now comes the moment I promised you at the start. A glowing orange stream of glass is pushed out through an opening at the bottom of the channel. Specialized shears slice it into even portions, one after another, several every second. Each severed piece is a future marble. Right now it's shapeless, red hot, and soft, like caramel. And then the beautiful part happens. The blob falls onto two tilted rotating spirals, two steel screws lying side by side. They turn towards each other and slowly roll the glowing blob down the trough. No moulds, no presses. The soft glass simply rolls, and as it rolls, it gathers itself into a perfect sphere. Physics does the work. Liquids have surface tension, and surface tension always pulls a blob towards a sphere, because a sphere is the shape with the smallest possible surface. Nobody gives the marble its shape. The marble wants to be a sphere, and the machine simply gives it enough time to get there. While it's rolling, the color goes in. Thin streams of colored glass are injected into the clear flow just before the shears. And as the marble rolls itself round, those streams twist inside it into the swirls, cat's eyes and ribbons we all recognize. No two patterns are ever identical. From that point of view, every marble in the world is unique. Next comes the most underrated and most critical stage of all. You can't just leave red-hot marbles to cool in the open air. The outside would cool fast while the inside stayed hot, and that creates enormous internal stress. Such a marble can shatter from a light knock and sometimes cracks on its own, just sitting on a table. So the marbles travel through a long tunnel called an annealing layer. Inside, the temperature drops gradually along its entire length, very slowly, hour after hour. The marbles come out cold and, most importantly, calm, with no stress trapped inside. That's exactly why a good marble can be thrown onto concrete and survive. After annealing comes inspection. The marbles roll down calibrated channels. Anything the wrong size is rejected automatically. Cameras and operators catch defects, air bubbles, chips, uneven shapes. Rejected marbles aren't thrown away. They're crushed and sent back into the furnace. The loop closes, waste becomes raw material again. The finished marbles are washed, polished, and packed into nets, jars, and bags. A large factory can produce them by the millions every single day, which is where the billions of marbles figure comes from across the industry. And here's the surprise. Children's games are no longer the main customer. A huge share of glass marbles never reaches a playground. There's a marble inside every spray paint can. That's the ball that rattles when you shake it, mixing the paint. Marbles are used in water filtration, industrial sandblasting, decoration, and landscaping. Tiny glass microspheres are mixed into road paint. They're what reflects your headlights and makes the white lines glow back at you at night. There are marbles in chemistry, labs, and even inside some bearings. What we think of as a toy, industry takes very seriously. So the next time you see a glass marble, in a child's box, in a vase, or rattling inside a can of spray paint, remember what you're holding. A mountain of discarded bottles, melted at a temperature hotter than lava, colored with dissolved metal, sliced midair by shears and rolled into a perfect sphere by 2 spinning screws, simply because molten glass wants to be a sphere, a toy with a 400-year-old world championship and a history thousands of years long. One of the most ordinary things on Earth, and one of the most extraordinary. If you enjoyed this journey, hit that like button and tell me in the comments which everyday object we should tear apart next. Subscribe. Next week, we crack open another industry nobody thinks